This is Swathi, working as Assistant Professor in the Department of Electronics and Communication Engineering in Institute of Aeronautical Engineering, Dundigal. Welcome to this lecture. In this lecture, we'll be discussing about the complements of numbers and what is the importance of complements. First of all, how many types of representations of numbers are there? That means in how many ways a binary number can be represented. That is unsigned binary representation, signed binary representation, and complement of numbers. And then again in complements, how many types of complements are there, and what is the significance of complements, and where we use the complements. And coming to that, all types of complements, we'll be discussing about R's complement and R minus complement, R minus 1's complement. So, and also we will be doing some arithmetic operations using complements, that is R's complement and R minus 1's complement. So, let us enter into the topic now. First of all, representation of binary numbers. So, any binary number can be represented in signed and unsigned way. So, binary representation is of two types, that is unsigned representation and signed representation. What do you mean by unsigned representation? That means we cannot represent any negative numbers in this representation. We can have only positive numbers. That means any number that is represented in this one can be considered as a positive number. And coming to the unsigned signed magnitude representation, so we can have both positive and negative number. That means we can represent both positive and negative numbers in terms of binary. So that is signed representation. So in that signed representation, again it is classified into three types. That is signed magnitude representation, 1's complement representation, 2's complement representation. So what are all these and why we are going from one representation to the other representation, we'll see. So I hope it is clear. Binary number can be represented in two ways, unsigned and signed. Unsigned means this can be used to represent only positive numbers. Where we want to represent negative numbers also, we'll be going for the signed representation. Again, the signed representation is of three types: signed magnitude form, 1's complement form, and 2's complement form. Okay, so here here I have written one comment on each and every representation. Unambiguous 0, that is only 1 0. Whereas signed magnitude representation, ambiguous 0, that is we have two representations for 0. That is ambiguous because we can have only one representation for 0. But here in signed magnitude form, we can have two representations for 0. So that is ambiguous. Whereas coming to the 1's complement and form and 2's complement form, again we have two representations for 0 in 1's complement form also, so which is ambiguous, that means controversial. And 2's complement, it is unambiguous, that means only one representation is there for 0. So this is about binary representations. Now let us see in detail about unsigned representation or else unsigned numbers. Unsigned numbers do not have any signed bit. So every number will be considered as a positive number and all the bits will constitute the magnitude of a number. As there is no signed bit, so all the n bits in a binary number will constitute the magnitude only. So the 0 is an ambiguous number. That means in unsigned representation, 0 can be represented as with only one representation, that is there is no negative 0, because in unsigned representation all numbers are considered to be positive. So that is why the unsigned 0, the 0 is also unsigned. That means we have only positive 0, we don't have any negative 0, because in unsigned representation we don't represent negative numbers. And every number in unsigned number represent has only one unique binary equivalent form. So, and coming to the range of unsigned binary numbers, for example, we have a 2-bit binary number. We have a 2-bit binary number. In unsigned representation, the range of values that can be represented using 2 bits varies from 0 to 2 power n minus 1. That means I can represent what is n here, n is equals to 2. So that means 0 to the range of values 0 to 2 power 2 minus 1. So what is the value here? 2 power 2 is 4 minus 1 is 3. 0 to 3 we can represent in unsigned representation. Where in unsigned representation 0 to 3 can be represented using two binary digits. That is, let us consider AB. So 0 can be represented as 0 0. 1 can be represented as 0 1. 2 can be represented as 1 0. 1 1 can be represented as 1 1. Okay, so that is 3, 2 and 3. So that is the meaning of this one. So the range of values that can be represented, or else the range of unsigned binary numbers, always varies from 0 to 2 power n minus 1, where n is the number of bits in a given number. Okay, so this is about unsigned representation. So for example, we will consider two problems. So represent a decimal number 92 in unsigned binary number. So as I told you that in unsigned there is no negative number, all the numbers are considered to be positive, and all the bits of an unsigned binary number will constitute a magnitude. Now this is a decimal number. I want to convert it into unsigned binary. So how to convert a decimal number into binary? We already know the procedure. What is that? We have to divide this one by 2. We have to divide this one by 2. So if you divide this one by 2, what you will get? 92. So 2 4s are 8. 2 6 are 12. So remainder is 0. 2 2s are 4. Next 2 3s are 6. Remainder is 0. 2 11s are 22. The remainder is 1. 2 5s are 10. Remainder is 1. 2 2s are 4. Remainder is 1. 2 1s are 2. The remainder is 0. And finally the answer is 1 0 1 1 0 0. So this is the answer. So now we'll verify. Let us verify whether the magnitude is same or not. So I'm just verifying the magnitude. What is the position of each bit? 0 1 2 3 4 5 6. As the number of bits is 7, so the positions will vary from 0 to n minus 1, that is 0 to 6 minus 7 minus 1, that is 6. So now 1 into 2 power 6 plus 0 into 2 power 5 plus 1 into 2 power 4 plus 1 into 2 power 3 plus 1 into 2 power 2 plus 0 into 2 power 1 plus 0 into 2 power 0. So finally the magnitude you will be getting it as 92. So this is the unsigned representation. The thing you have to remember here is, in unsigned representation there is no negative number. All the numbers are considered to be positive, and all the bits of a binary equivalent will constitute a magnitude. There is no sign bit. So that is the thing that you have to remember. And consider the next one. Find the range of 5-bit unsigned binary numbers. Also find minimum and maximum value in this range. So as I told you that the range of unsigned binary representation is 0 to 2 power n minus 1. So what is a bit? What is the number of bits given in the problem? 5 bits. So, and hence the range will vary from 0 to 2 power 5 minus 1. What is 2 power 5? 32. 32 minus 1 is 31. So 0 to 31, and 0 can be represented as it is given. It is 5 bit. How a 0 can be represented in 5 bit? All zeros, 5 zeros. To 31. 31 means all 5 ones will give you 31. So it is 0 plus 1 plus 2, 3. 3 plus 4, 7. 7 plus 8, 15. 15 plus 16, 31. So these are the range of values of an 5-bit unsigned binary number. So the minimum value is 5 zeros to 5 ones. Okay, so this is the thing about unsigned representation. Now coming to the signed numbers. So signed numbers contains a sign bit. Okay, so there will be a sign bit with which we can represent both positive and negative numbers. Okay, so if the sign bit is 0, then the number is considered to be positive. If the sign bit is 1, number is considered to be negative. That means we have an extra bit which represents the sign of a number. If the sign bit is 0, that number is considered to be positive. If the sign bit is 1, the number is considered to be negative. So for example, if we have an n-bit number, then the first, that is MSB bit, is considered to be a sign bit, whereas the remaining n-1 bits are constitute the magnitude of the number. Okay, so that means, for example, we have an 8-bit number 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8. So that means 0, 1, 2, 3, 4, 5, 6, 7. Right? So this bit is considered to be sign bit. MSB is considered to be sign bit, whereas all these bits will constitute magnitude. All these bits will constitute magnitude of the number. If the sign bit is 0, then the number is positive. If the sign bit is 1, the number is considered to be negative. So for example, if I want to represent 0 in sign magnitude representation. So how can I represent a 0? So I can have I want to represent 0 in 5 bits. So then 0, 0, 0 can be represented positive, that is plus 0. If this is the sign bit, as I told you that MSB is always considered to be sign bit. If it is 1 and all are zeros, then what happens? It is considered to be negative 0. Do we have a positive 0 and negative 0? It is an ambiguous case. So we should not have positive 0, negative 0. 0 means 0, that's it. There is no negative or positive 0. There is no polarity for the 0. So this is the limitation of sign magnitude number representation. What is that? There are two representation for 0, where it leads to an ambiguous condition, and hence this representation is not that much useful. And here, as we are using, as I told you that MSB is a sign bit, and only 0 to n-1 remaining n-1 bits constitute the magnitude. So here now and hence we can say that the range of values of this sign magnitude representation will be varying from 2 power n-1 minus 1 to the 2 power n-1 plus 1. Okay, so this is the range of values of sign magnitude representation, and it is disadvantageous because we have two representations for the sign magnitude representation. So here the value of sign bit is 0, then the given number will be considered as positive. If the value of the sign bit is 1, then the given number will be considered as negative. The remaining n-1 bits represents the magnitude of the number. So that is about the sign magnitude representation. And now we'll be looking at into the complements. So before going to the complements, okay. So what do you mean by complement here? So the complements are used in digital computers in order to simplify the subtraction operation. How we are going to simplify the subtraction operation? Generally, the complement of a number, negative number, will be considered as complement of a negative number. Complement of a negative number is considered to be positive. Number is considered to be positive. So first of all, why we are going for the complements considered to be positive? So here, whenever you are implementing any processor, you need to go for, you always will be taking care of miniaturization. Means you want to design a circuit such that less number of components are required. So instead of having separate circuitry for performing addition and subtraction, if you can perform the addition and subtraction using a single circuit, then you can reduce the number of components required for implementing any circuit, right? So that means, for example, ALU you want to design, arithmetic and logical unit. So if you can perform addition and subtraction using both adder only, then you cannot, it is not needed to have a subtractor circuit separately. So that is why we are going for the complements, where the complement of a negative number is considered to be positive, and hence if I want to perform A minus B, then as I told you that the complement of B will be, B is a negative number, So if I find the complement of b, then it will be converted into positive number, where this one is nothing but complement of minus b. Complement of minus b. So what we are doing, by finding the complement of negative number minus b, we are able to convert the subtraction into addition, which can be performed by using the adder itself. So that is the representation. And also, as a sign magnitude representation is ambiguous, because we have two representations for 0 where it is not possible here. That is why we are also going for the another representation, which is nothing but complements representation. Okay, so here again in this complements we have two types. One is the r minus 1's complement, and the second one is the r's complement. R minus 1's complement is also called as diminished radix complement. Diminished radix complement. As you all know that R stands for radix. So R minus 1's complement means diminished radix complement. What we are doing, we are subtracting 1 from the radix. So that is why we are calling it as diminished radix complement. And the R minus 1's complement of a number in any number system with base R can be found out by subtracting every single digit of a number from r minus 1. Okay, so that means we have so many number system with base r, right? So of any number system, the complement of r minus 1's complement can be obtained. Why we are going for the complement? In order to convert a negative number into positive number, such that the subtraction is also possible by the adder, right? So any number system, the number in any number system with the base r, complement can be found out by simply subtracting each digit of the given number from r minus 1, where r is nothing but base. Okay, so like that, what is r minus 1's complement for a binary number system? For a binary number system, r minus 1, that is 2 minus 1, so which is equals to 1's complement. So how can I find out the 1's complement here? So what I said, I can find out the r minus 1's complement of a number by subtracting each digit of the given number from r minus 1. So what is r minus 1? 1. So a binary 1's complement can be obtained by subtracting each digit of the given binary number from 1, where 1 is nothing but r minus 1, which is 2 minus 1, where 2 minus 1 is 1. That means each digit of the given binary number should be subtracted from 1, so that the 1's complement of a binary number can be obtained. Okay, so that is the example. For example, we have an octal number system. What is the base of octal number system? Base is r. R is equals to 8. Then what about the r minus 1's complement of octal number system? Octal number system, r minus 1's complement is said to be 8 minus 1, which is nothing but 7's complement. Now, how can we find out the 7's complement of a number? So how can we find out the 7's complement of a number? So each digit of a octal number can be subtracted from 7, so that the 7's complement of an octal number can be obtained. For example, here 347 is my octal number. Now I want to find out the 7's complement. I want to find out the 7's complement, which is nothing but diminished radix complement. Right? So how can I find it out? So simply by subtracting each digit. How many digit number it is? 3 digit number. So I have to take 3 sevens, and each digit should be subtracted from 7. So 0, 3, 4. 430 is the 7's complement of given number. 7th complement of given number. Now, what about decimal number system? Decimal number system, r is 10. What is r minus 1's complement? R minus 1's complement will be 9's complement. Now, how to find out the 9's complement of a decimal number? For example, 1258.98. This is my decimal number. Now, I want to find out r minus 1's complement. R minus 1's complement. So what is r minus 1's complement? That is 9's complement, because the base is 10 here. So that is why r minus 1's complement is what? 9's complement. So how can I get the 9's complement? How many digits are there in my decimal number? 5 digits. So I need to take 5 9's. Okay, and each digit of the given number should be subtracted from 9. Okay, so here now 9 minus 8, it is 1. 9 minus 9, 0. Point, decimal point as it is we should keep. 9 minus 8, 1. 9 minus 5, 7. 5. 9 minus 8. This is the 9's complement of number 1258.98 is this one. This is the 9's complement of the given number. So similarly, for example, I have a number ABC.EF. This is my hexadecimal number. So what is the R minus 1's complement? R minus 1's complement of hexadecimal number system? R is 16. R minus 1 means 15's complement. 15's complement of a given number. So what is 15 represented in hexadecimal number system? F. So that means each digit should be subtracted from F in case when we want to get 15's complement. F point FF. Then I have to subtract each digit from F. So F is 15. 15 minus 15, 0. And F is 15, E is 14. 15 minus 14, 1. Okay. Next, F is 15 and C is ABC. C is 12. 15 minus 12, 3. Next, 15 minus 11, it is 4. Next, 15 minus 10, it is 5. 523.10. This is nothing but 15's complement of given number ABC point EF. So I hope it is clear. So any number system, if it is given, if you want to find out the R minus 1's complement, then each digit of a given number should be subtracted from R minus 1 so that we can obtain the R minus 1's complement. And one more thing you have to remember, once we are getting the complement, it indicates that changing the positive number into negative number or negative number into positive number, vice versa. Okay, so complementing means changing the sign of the number. Okay, so this is R minus 1's complement. Now what about R's complement? So the R's complement is also known as Radix complement. R's complement is also known as Radix complement, whereas R minus 1's complement is also known as Diminished Radix complement because we are subtracting 1 from the Radix. So that is why it was Diminished Radix complement, whereas this one is Radix complement. So how to find out the R's complement of a non-zero number in any number system with base R can be calculated by adding 1 to the LSB of its R minus 1's complement. So here R minus 1, okay, plus 1. So what happens? This one get cancelled. So what you'll get? R's complement. So that is the meaning here. So what we need to do in order to get the R's complement of a given number of any number system R can be obtained by simply adding 1 to the least significant digit of its R minus 1's complement. Okay, for example, now I have a binary number 001. Now I want to get the 2's complement of a binary number 001. How can we calculate? First get the 1's complement, okay, 001, then 1's complement of 001. So how can we get the 1's complement? 111 minus 001. Each digit should be subtracted from 1, right? 0, 1, 1. So this is the 1's complement. Now after getting the 1's complement, add 1 to the LSB of 1's complement. So LSB, this is the least significant bit. I am adding 1. So 0 plus 1, 1, and it is 1, 1. So this is the 2's complement of the given number. 2's complement of the given binary number. Okay, so this is about the R minus R's complement. This is in case, that means in order to find out the 2's complement of a binary number, first find the 1's complement, that is R minus 1's complement of a binary number, and then we need to add a 1 to the LSB of 1's complement, so that we will be getting the 2's complement. And one thing you remember, here, for example, we have taken 0, 0, 1. What is the 1's complement of this one? We have got 1, 1, 0. Similarly, if I take 1, 1, what is the 1's complement? How can you get the 1's complement? 1, 1, 1 minus 1, 1, 1. So what is the answer? 0, 0, 0. That means if you observe these two, the 1's complement of a given binary number can be simply obtained without subtracting each digit from 1. By simply looking at the number itself, we can tell the equivalent, that is 1's complement of a given binary number, simply by changing 1's to 0's and 0's to 1's. So that means, for example, 1, 1, 0 is there. What is the 1's complement of this one? Simply change the 1's to 0's and 0's to 1's. So 0, 0. This is the 1's complement of the given number. Even if you do the same thing, 1, 1, 1 minus 1, 1, 0. So how much you will get? 1 minus 0, it is 1, 0, 0. So this and this are same. Either you can subtract 1 from each digit, or else simply change the 1's to 0's and 0's to 1's. So this only is applicable for 1's complement, not for 9's and 7's or 15's complement. This is only applicable for 1's complement, simply can be obtained by changing 1's to 0's and 0's to 1's in a given binary number. Now, I have an octal number 347. Now, I want to get the 8's complement of 347. How to get the 8's complement? 8's complement is equals to 7's complement plus 1, right? 7's complement plus 1. So what is the 7's complement of 347? So 7, 7, 7 minus 347. How much I'll get? 0. 7 minus 4, 3. 7 minus 3, 4. 430. 430 is the 7's complement, right? So 430 plus 1. So how much I'll get? 431. This is the 8's complement of the given binary number. Okay, sorry, given octal number. Similarly, if I have a decimal number like this, for example, I have 10 AB point C A. This is my hexadecimal number. Now I want to find out 16's complement. 16's complement. How to find out the 16's complement? 16's complement is equals to 15's complement plus 1. 15's complement plus 1. What is the 15's complement? 15's complement is F point F, because 6 digits we have. 10 AB point CA. So how much I'll get? 15's complement minus F minus A. 15 minus A, that is 5. 15 minus 12, 3. 15 minus 11, it is 4. 15 minus 10, it is 5. F. And this one is E. 15 is, F is 15. 15 minus 1, 14. 14 is represented as E. So this is my 15's complement. This is 15's complement. Right now, add LSB. If you are taking LSB after the point, whatever the least significant we have, that to that we have to add. Not here. To 5 we need to add 6, 3.45 F5. This is the 16's complement. Okay, like that you can find out the any complement here. Simply by R's complement can be obtained by simply adding 1 to the R minus 1's complement. This is the mathematical representation of R's complement and R minus 1's complement. The Radix complement and diminished Radix complement are defined as, I am representing n base R. E is an n digit number, okay, small n digit number, n in base R. So n is the n digit number with base R. Whatever it may be the base. R may be either 2, 8 or 10 or 16. Is the R's complement, a square bracket, and R represents the R's complement of number n. So next R minus 1, this one represents the R minus 1's complement of number n to the base R. So here I can find out the R's complement of the number by simply subtracting R to the power of n minus n to the power of R. Okay, minus number. So R to the power of n. So for example, I have a decimal number system where the decimal number system R is equals to 10. R is equals to 10, right? So now I want to find out r's complement. Now I have to find out r's complement. So what we need to do? R's complement can be find out simply by subtracting. For example, let us consider 1, 2, 3, 1, 2, 3, 4. This is my decimal number. I want to find out tens complement for this one. So the tens complement can be found simply by subtracting the number from r to the power of n. How many digit number it is? 4 digit number. So that is why 10 to the power of 4 minus number 1, 2, 3, 4. 10 to the power of 4 means 1, 0, 0, 0, 1, 2, 3, 4. So how much I'll get? 9, 9, 9, 9, 9, 10. This is 6 and this one is 6, 7, 8. This is the answer. So even this is the tens complement. You can do like this, or else you can find out the r minus 1's complement. So how can I find out the r minus 1's complement? Subtract each digit from 9. 1, 2, 3, 4. So how much I'll get? 9 minus 4, it is 5. 9 minus 3, 6. 9 minus 2, 7. 9 minus 1, 8. Plus 1. So how much? 6, 6, 7, 8. This is tens complement. So that means either this way you can do or this way I can do. So that means simply subtracting a number from r to the power of n will give you the r's complement. And once r minus 1's complement, how can I get the r minus 1's complement? Simply by subtracting 1 from r's complement, I'll get the r minus 1's complement. So if I subtract 1 here, what I'll get? 9's complement. What is a 9's complement? This is my 9's complement. If I subtract 1, 8, 7, 6, 5, I'll get. So either this way or this way. That means first you get the r's complement and subtract 1, then you will get the r minus 1's complement. Or else first you get the r minus 1's complement and then you add the 1 to the r minus 1's complement so that you can get the r's complement also. Either of the way you can do it. So this is a mathematical representation. So equation 1 and 2, we can also derive the following equations. So n into n, that is r's complement of number, which is this one, is obtained simply by n r minus 1's complement plus 1, or else r minus 1 can be obtained as r to the power of n minus 1 minus nr. So these are the mathematical equations for representing complements, r's complement and r minus 1's complement. Now let us see 1's complement of a number. So how can we get the 1's complement of a number? So as I told you that simply by changing 1's to 0's and 0's to 1's, we can get the 1's complement of a given number. For example, this is my number. The 1's complement can be obtained simply 1 to 0, 0 to 1, 0 to 1, next 1 to 0. So like that. So what is our number here? 1, 1, 0, 1. 0, 0, 1. So the 1's complement can be obtained simply by changing 1's to 0. So this is 1, 0, 0, 1, 0, 1, 1, 0. So this is the 1's complement. And how can I get the 2's complements? Once the 1's complement is obtained, just add 1 to this one. So that 1, 1, 1, 0, 1, 0, 0. So this is the 1's complement. So r's complement can be obtained simply by adding 1 to the r minus 1's complement. Now 9's complement and 10's complement. So here, if it is a subtraction of decimal number, can be accomplished by the 9's and 10's complement method. So the 9's and 10's complement method similar to the 1's and 2's complement method of binary. So the 9's complement of a binary decimal number can be simply obtained from by subtracting each digit from 9. And the 10's complement of a decimal number can be easily obtained by adding 1 to the 9's complement. So here this is my number here 2457. So 2457 is my decimal number. I want to calculate 9's complement. So 9's complement, how can I get it? 9, 9, 9, 9, 2, 4, 5, 7. Now subtract each digit from 9. So 2, this is 7, this is 7, this is 2, and this is 5 and 7. 7, 5, 7, 5, sorry, it is 4. 7, 5, 4, 2. So this is the 9's complement. 10's complement, just add 1 to the LSB. 7, 5, 4, 3 will be the 10's complement. Okay, so like that we can perform any for example, For example, let us have a number of a base anything. Let us consider a number with base 6. Okay. So for example, a number 1, 2, 3, 4, 5 is my base 6 number. Now I want to find out r minus 1's complement and also r's complement. What is the base here? R is equals to 6. Now what is r minus 1's complement? Which is equals to 5's complement. How can I get the 5's complement? Subtract each digit of the given number from 5. That is 5, 5, 5 minus 1, 2, 3, 4, 5. This will give you 0, 1, 2, 3, 4. So this is the 5's complement. So now I want to get the 6 complement. So plus 1. So 4, 3, 2, 1, 1, which is the 6's complement of the given number 1, 2, 3, 4. Okay. So like that you can perform, you can calculate r's and r minus 1's complement of any number system. Okay. So that is about complements. So as I told you that in order to simplify the arithmetic operations, we are going for the r's complement and r minus 1's complement. So how to perform the subtraction operation using r's complement and r minus 1's complement? That is the question here. So r's complement. So here whenever you are performing the subtraction, we have just a second. Whenever you are performing the subtraction, we will always consider the numbers as a and b, a minus b. So the number which is going to be subtracted is called as subtrahend. So this is b is called as subtrahend. B is called as subtrahend and a is called as minuend. A is called as minuend. From which we are subtracting is a minuend, and which we are subtracting is called as subtrahend. That means what we are doing, we are subtracting b from a. B is subtracted from a. So that means a is called as subtrahend and b is called as subtrahend and a is called as the minuend. So where subtrahend is a negative number and this one is a minuend. So whatever it is, even we may have minus a plus b also, then this one. So what we need to do is make the minuend and subtrahend equal by adding zeros. Sometimes we may not have equal number of digits in the two numbers. So we need to make them equal length by adding zeros. In which positions we need to add? Extreme ends, that is to the MSB position. Okay, that is to the MSB position. Then only the value of the number will not be changing. So add the zeros so that the number of bits in each or its number of digits in each number will be equal. Okay, and then find the r's complement of subtrahend or else negative number. Okay, r's complement of subtrahend or negative number, and add minuend to the r's complement of subtrahend. That is, add the positive number to the r's complement of negative number or else minuend to the subtrahend, r's complement of subtrahend. Then if the sum produces the carry, then discard it. Okay, so if while we are adding the a to r's complement of b, if a carry is resulted, then discard the carry and the sum is considered to be positive, or else the difference is considered, the result is considered to be positive. If we don't have a carry, then the result is considered to be negative and the result should be taken again. Again we should take the r's complement of the result and put a negative sign before that. So these are the rules for performing the subtraction operation using r's complement. Whatever it may be the number system, if you want to perform the subtraction using r's complement, this is the procedure. First find the r's complement of the negative number or else minuend, and then add the subtrahend r's complement of subtrahend or negative number, then add minuend to the r's complement of subtrahend. If the addition produces any carry, then discard the carry. If it does not produces any carry, just consider the result as negative, and the result is to be calculated by again taking the r's complement to the sum. Okay, and putting a negative sign before. So these are the rules that are to be followed whenever you are doing the subtraction using R's complement. Okay, so these are some examples. We'll be discussing these once we look at the procedure for subtraction using R minus 1's complement also. So subtraction using R minus 1's complement. So again, the same rules will be applied. The same rules will be applied to the R minus 1's complement also. So what we need to do whenever you are performing A minus B, take the R minus 1's complement of the negative number or else subtract. Okay, where in the previous case, we have taken the R's complement of the negative number. Now in this case, R minus 1's complement of the negative number is to be calculated. Once it is done, then add the R minus 1's complement to the minuend. If a carry is resulted, then that carry is to be added to the least significant digit of the sum. And that carry is called as end around carry. Why it is called as end around carry? Because we are adding it again back to the least significant digit of the sum. So that is why we are calling it as end around carry. So in case of R's complement subtraction, what we are supposed to do, if a carry is generated, just ignore the carry or discard the carry, and the result is considered to be positive. If a carry is generated in R minus 1's complement subtraction, then add it to the least significant digit of the number, and it is said to be end around carry, and the result is considered to be positive. And again in the same as the previous case, if no carry is resulted, then the result is considered to be negative, and the result is calculated by taking again the R minus 1's complement of the sum and putting a negative sign before. So same steps, only the difference is if carry is generated, we are just adding it to the least significant digit. Whereas in that case, we are just ignoring the carry. And in both of the cases, if no carry is generated, result is negative. That is a negative of the R minus 1's complement of sum. So this is about the complement and the procedure for performing the subtraction using complements. Now let us take this one, 76425 minus 28321. We'll perform the subtraction using 9's as well as 10's complement. Okay, so let us try to do this one. First one, 76425 minus, what is the question? 28321. 28321. Perform the subtraction. Okay, perform the subtraction. This is the question. Perform the subtraction using R's and R minus 1's complement. R's and R minus 1's complement. He didn't mention directly. So here it is given base 10. Base 10 means what? It is a decimal number. What is R here? 10. Then R's complement means what? 10's complement. R's complement is 10's complement. R minus 1's complement means what? It is 9's complement. We need to identify this if it is not given. So first of all, let us do this one directly. 76425. In either of the way you perform the subtraction, the result should be same. Okay, so 28321. This is a direct subtraction result. 5 minus 1, 4. 0. 4 minus 3, 1. 6 minus 8, not possible. So 16 minus 8, 8. And here one borrow we have taken. So it is 6 minus 2, it is 4. This is the answer. This is the answer. It is positive, right? So now what we need to do? We are performing the same thing using 9's complement. 9's complement subtraction. 9's complement subtraction, right? So now how to do that? Okay, first step. Let us consider A is equals to 76425, where B is equals to 28321. So the 9's complement of B. 9's complement of B is, how to get the 9's complement of B? 9, 9. How many digit number it is? 5 digit. 5 digit number. So I'm taking 5 9's and I'm subtracting 2, 8, 3, 2, 1 from 9. So what I'll get? 8, 7. This 9 minus 3, 6. 9 minus 8, 1. 9 minus 2, 9 minus 2, 7. So this is the 9's complement. Now we have A and the 9's complement of B. 9's complement of B. So perform the addition. A is 7, 6, 4, 2, 5 and the 9's complement of B is 7, 1, 6, 7, 8. 7, 1, 6, 7, 8. So as we have got the complement, so the negative number is now became positive number. Now add these. So now if I add this, 5 plus 8, 13. So it is 1. As it is decimal number, all the digits are allowed here. So it is 10, it is 0 and 1. So it is 11. Okay. And it is 8 and this one is 14. 1 is considered to be carry. So as we are performing R minus 1's complement subtraction. So this carry is called as end around carry. That means what we need to do? We need to add it to the least significant digit. So we are adding it to 3. So 3 plus 1, 4, 0, 1, 8, 4. This is the answer. So this one and this one are matched. So this is the answer. Now coming to the tens complement subtraction. Tens complement subtraction. So in this also I have to get the, so as we have got the carry, the result is positive, right? Tens complement subtraction. So tens complement subtraction. Now get the tens complement of B. Tens complement of B is equals to 9's complement plus 1. So what is the 9's complement we have got? That is 7, 1, 7, 1, 6, 7, 8 plus 1. So how much I'll get? 7, 1, 6, 7, 9. Now A, what is the value of A? 7, 6, 4, 2, 5 and tens complement of B, which is equals to 7, 1, 6, 7, 9. So 9 plus 5, 14 and this one is 10 again. Okay, this one is 11 again and this one is how much? 8 and this one is 14. So in case of tens complement subtraction, if we have a carry, just discard the carry or else ignore the carry and the result is considered to be positive. So this is the result. So in all the cases 48104 is the answer. This is the way of performing the subtraction using R's complement and R minus 1's complement. I hope it is clear. Now let us take the one more problem, that is subtraction using subtraction of binary numbers using 1's complement. Okay, so now I'm taking or else here only I'll do. So I'm taking the second one. So 1 1 0 1 0 0 1 1, right? So 1's complement of negative number. 1's complement of negative number. What is the negative number? 1 0 0 0 1 1 0 0. What is the 1's complement? 0 1 1 1 0 0 1 1. I'm just directly converting. Now add these. 1 plus 1 0 with a carry 1. 1 plus 1 plus 1. 1 with a carry 1. 1 0 0 with a carry 1. 0 with a carry 1. 1 with a carry 1. 0 with a carry 1. So here again we have got a carry. Now we have to add it to the least significant digit. 1 1 1 0 0 0 1 0. This is the 1's complement subtraction. Okay. Now answer is this is the 1's complement subtraction here. And now coming to the second one. This is the answer here. Now coming to the 2's complement subtraction. 2's complement means we need to add 1 to the 2's complement. 2's complement of 1 0 0 1 1 1 0 0 1 1 0 0 is equals to 1's complement plus 1. What is 1's complement? 0, 1, 1, 1, 0, 0, 1, 1 plus 1. So how much I'll get? 0 with a carry 1, 0 with a carry 1, 1, 0, 1, 1, 1, 0. This is the 2's complement. Now add it to the next positive number. What is a positive number? 1, 1, 0, 1, double 0, double 1. So what is a 2's complement? 0, triple 1, 0, 1, 0, 0. Now add it. So 1, 1, 1, 0, 0 with a carry 1, 0 with a carry 1, 1 with a carry 1, and then again 0 with a carry 1. So here this is the carry we have got, and add as it is the 2's complement subtraction, discard the carry, then the final answer is 0, 1, 0, 0, triple 1. Actually I have given this is the answer, but this is wrong. This is the correct answer. This is the correct answer. So this is the answer here. So in both the ways we have got the same thing. We'll do the direct subtraction. 1, 1, 0, 1, 0, 0, 1, 1. Direct subtraction I want to do. 0, 0, double 1, 0, 0, right? So 1 minus 0, it is 1. So this is direct one. I'm cross verifying whether it is correct or not. 1 minus 0, it is 1. So here again 0, 1, 1, 0, because we cannot subtract 1 from 0. So that is why that is 1, and 1 minus 1, it is 0, and it is 0. It is 0. 1 minus 0 is 1, and this is 0. So 0, 1, triple 0, triple 1. So this is the answer in all the three cases. This is 1's complement subtraction, this is 2's complement subtraction, and this is direct subtraction. So in all the three cases we have got the same answer. So this is the 2's complement subtraction of binary numbers using r's and r minus 1's complement. Now let us take this one, 257 minus 165. Okay. 267 is an octal number. 165 it is also an octal number. Perform the subtraction using 7's and 8's complement. First let us do the same thing. 267, 165. 7 minus 5, it is 2. And 6 minus 6, it is 0. And 1 minus 2 minus 1, it is, this is the direct subtraction. Right? Now we'll verify. First 7's complement. 7's complement subtraction. Okay. So first 7's complement of negative number. Negative number is 165. Is how to get it? 777 minus 165. So how much I'll get? 2. 7 minus 6, it is 1. And 7 minus 1, it is 6. So this is the 7's complement. Now the number A, that is 267, and the 7's complement of 165 is 612. Now we have converted the negative number into positive number. 7 plus 2, it is 9. 7 plus 2, it is 9. Is it a valid octal number? No, it is not a valid octal number. Valid octal digits are 0 to 7 only. But what is the sum we have got here? 9. So 9 is a decimal number. Now I want to convert it into octal number. How to convert a decimal number into octal? Divide by 8. 8 ones are 8 and it is 0. So that is 1 0. So 0 should be placed here and 1 is placed here. Okay. 0 with a carry 1 we have to consider. So again 1, 8. 8 is again not a valid. Sorry, it is 1. Okay. So again 8 is not a valid octal number. So again we have to divide it by 8. So 8 ones are 8 and the remainder is 0. So 0 and it is 1. So that means 8 decimal number can be represented in octal as 10. In octal as 10. So 0 we have to place in the sum position and 1 should be carried to the next digit. So it is 9 again. So now 9 is represented as 1 with a carry 1. We have got a carry. So if we have a carry as it is r minus 1's complement and around carry, just add it to the least significant digit and the answer is considered to be positive, whereas this and this are same. Now coming to the 8's complement subtraction. 8's complement subtraction. Okay, so 8's complement subtraction. So what we need to do, 8's complement of 165, so which is nothing but 7's complement plus 1. What is the 7's complement? We have got 612 plus 1, which is 613. This is the 8's complement. Now get the number 267 and 8's complement of 165, which is 613. So now add this. So it is 10. 10 in octal can be represented as 1 1 octal. So 1 1 or 1 2. 1 2. So 2 with a carry 1. Okay. 2 with a carry 1. So again it is 8. 8 again can be represented as 0 with a carry 1. So 9. 1 with a carry 1. So again carry we have got, just discard the carry. Discard the, because it is R's complement. Discard the carry and the final answer is 102. So this is the way of performing the subtraction using R's complement and R minus 1's complement. I hope it is clear to you all. That is, so even you can find some more problems here. That is 4AB 0.68 minus 507D.56. So here also you can find some more problems. You can try this, and if you have any doubt, you can just post it in the comment section so that I can revert back. In this lecture we have discussed what are the various representations of the numbers. What do you mean by signed representation, unsigned representation, and complements of numbers, and what are the types of complements, 1's complement, 2's complement, and how to perform the subtraction using R's complement and R minus 1's complement. Just keep the rules or else steps of performing subtraction using R's complement and R minus 1's complement. Then you can perform the subtraction of any numbers of two numbers of any number system by applying those rules. I think it is clear to you all. That's all for this lecture. Thank you everyone.
Like, share and subscribe. Hit the bell icon for more updates.